Quickly switch to the correct slide deck, and there we have it. Okay, so let me just start. Hello and welcome, people of this meetup. Welcome to my talk, my very first talk, named Contextual Template States. And this is, as you already can guess, about Angular and the template, but not about how we actually bind the value, but everything around the value. So that means if we do asynchronous operations like fetching data from the network and want to display them as a list, then we get a context through our reactive data structures, and that's what this talk is about. Before we go into any further detail, let me quickly introduce myself. Hello, I'm Julian. I'm lead performance engineer and trainer and consultant for the company Pushbase of Michael Latke. Thanks for organizing all this stuff for us. I'm also, and that's more important for at least this talk, co-maintainer of the rxAngular library. And the rxAngular library is a library regarding developer experience and performance for Angular. So we not only care about runtime speed, we also care about developer speed. And when we're doing our work at Pushbase and working for different projects in different companies or for different customers, we usually try to find nice patterns to solve common problems in different applications. And whenever this happens, we try to extract it and document it very well and then release it via our set of libraries, which you can install via NPM. And this talk is about one specific set of features named contextual template states. So that should be enough of introduction information. So let's get straight into our theory part. So as I told you before, we are talking about reactive data structures because we want to handle contextual states coming from our HTTP client, for example. And in a typical Angular environment, you will see either a promise or an observable, which are your reactive data structures which you can use. There are definitely more, but those are the ones you typically see. So the promise itself is a native language feature of JavaScript, and it can be seen as a proxy object which eventually emits one value. Compared to the observable, which is also a reactive data structure, it is a data structure coming from a third-party library, rxJS, and it should emit multiple values over time. I won't go into very much of the detail when comparing those two, but there are just points we need to focus on in order to understand the reactive context. So this gets even more clear if we switch to the creation functions and look at the anatomy of those two. So, on the one hand, on the left side, is there a pointer or something? On the top. On the top? I'm too afraid to press the button. So, on the left side you see the creation function for promises, so the value creation part, and you see you can use two different channels. So, in a usual setup, you do some async stuff, and then you process one single value when your async stuff is done, and you resolve the promise. After that, the promise is resolved, and you pass the value to your consumer. In case of an error, you just call the reject method, and you can notify your consumer, no problem, your consumer about any error that occurred. On the other hand, we have the observable, which has three channels. It has not only the next, so that would be compared to resolve, but also error and resolve, error and complete. So the setup is the same, we do some async stuff, but here we can process multiple values. So think of an interval or a WebSocket connection, or just a feed like Twitter. And you have the possibility to call multiple times the next channel, inform your consumer about values, and then you can decide if you complete and give your consumer the sign that no value will ever come by again. For the error case, it's the very same. You just have a catch block and inform the error channel. So why is this important? Because it looks very boring. Because we can extract the contextual state out of this anatomy. And what is the contextual state? So we at rxAngular identified three different contextual states reactive data sources can provide to us. At first we have the suspense state. Suspense means no value was ever emitted, or null or undefined, so you don't have a value. Complete means no other value will be ever emitted again, so the stream ended, feed is over. Think of a pagination where you fetch one page and you display it as a stream. The error, obviously, when in case of any error, we have the context of the error. So, looking back at our anatomy of those two, we can identify those states directly inside of the creation function. For promises, you need to first notice that there isn't any distinguishable complete state, because resolve means terminate, so that's the very same, and you cannot distinguish between them anymore. Any promise will emit only one value. What we can actually see is the suspense state, which is happening right before you call the resolve method. There your template is suspended. In case of an error, we have the error context. Compare that to an observable, we notice we can process multiple values over time, and there's an additional channel to call the complete state. And this is all of our context we can derive from our reactive data sources. And why is this even useful? Because all of this together, the value and all the context we have, will in the end form our complete set of contextual template states. And just for comparison again, in the overview, for the promise we have a suspense, we have a next, so the actual value, think of a list of data, and we have an error context. For the observables, we just add an optional amount of next states, so different templates which we can process. And finally, we end up in either an error or a complete state. So that should actually be it, I think, for the theory part. And now I brought my keyboard, so I want to do some typing. And I've prepared a little demo roadmap with different use cases where we can make use of those contexts. So for the first, it's like a simple loading mechanism. You just fetch some data. While you don't have any data, you want to display some kind of loading spinner. And if an error occurred during a fetch operation, you just want to switch to an error template, and other way around, you want to display the list. Then we add a bit of complexity to the whole example and want to display some kind of continuous emitting stream, like a multi-shot example. Think of a Twitter feed, for example. And when it's finished, the list is complete, we want to display a complete template, so that we can use the complete context state. And in the end, we want to implement something that's even more complicated, because we need to switch between templates back and forth. Think of a search engine or something. You want to type and search for something, and while this is in progress, you want to show some kind of loading spinner or animation, and afterwards you want to show the result. So this is what you can expect now for the next, I don't know, 20-ish minutes, seeing me moving code around. And without further ado, I'd say I jump right into the code. Woo! I need to switch off the microphone. I hope I'm loud enough. If not, please say something. And also, I need to change my pointing device.
But I have a question.
Yes, of course.
Could you go back one slide or two slides, I think?
This one?
Yeah. Shouldn't this be between suspense and error? Shouldn't be complete? Because the promise complete, right?
Where? Here?
Yes, yeah.
Yeah, the thing is, then I need to go back 2 slides again. So for the promise, we cannot identify a real complete state, because the promises emit one value and then they are terminated anyway. So there's no real
Okay, so this is no state at all. Okay, that's
exactly.
what you mean. Okay.
You just emit the value, and if you emit the value, like via the resolve channel, then you would end up here in the next template. But otherwise, if you also consider complete for promises, you wouldn't have either next or complete. So, and we decided that it's the value, and the value is the next channel.
Okay, so this is a decision. Okay.
It's a design decision, but based on that, you cannot distinguish between the different states.
But
Yeah, yeah.
wouldn't it not be more appropriate if you just publish one next and then after this you immediately publish one complete?
But we didn't see any sense in it because it's always the same, like next and complete always is a follow-up. For the observable, you can have multiple next, and then a timeout, and then finally you complete.
Okay, because I'm just thinking if you did rxJS from promise, right?
Mm-hmm.
Then it did a next and then it did a complete.
Yeah,
Right?
it would do it.
Yeah.
Exactly.
That's why I'm thinking why. But it's fine.
Exactly, but that's then the point where you put rxJS on the native feature, and then you have the complete state as well. But the promise itself, at least it was our design decision to keep it as this. I think I'm set up. Okay, so let's start with the first example. Leave this one here, and maybe I start introducing, wait, let me go to the correct slide. Yes, okay, so here we are. We want to implement the simple loader and use our contextual state information in order to display different templates based on our context information. So let's first start and see the demo. So this is our demo application. Can anyone see it properly? Very good. Okay. So we have some buttons to control our state. So in order to reset everything and to raise an error, and this example should, if I now hit reset, show 2 seconds long nothing, and then switch to our list. So what is missing here is our context for suspense. So let's now dig into the code, because we actually want that if we click reset, we see a spinner, then our list. And if we hit error, we want our list to refresh and then result in an error. And if you see just right now, exactly, so I hit error. We actually got an error, but as we didn't implement the template yet, so that's our base setup. Close this one and go to the code. Exactly. Okay, application is served. Everything is all right. Demo 1. So our loading implementation. Let me quickly introduce you to the component setup. We have a simple component with one state creation method, and at this point we just emit a stream of a one-shot observable which emits one array of movies. So we use our creation function here to provide a template variable which we then can bind to in the template. And at this point in time, this is all you need to know about the component code. So let's switch quickly to the template. And we are starting here, like we have just the demo panel, simple title description, and here it gets a bit more exciting. So we predefine our error template and our loader template and give them a name. So in case you didn't know, you have no detailed information about Angular, I'm giving them a name. So I have a template called error and I have a template called loader. This should be our suspense template. So this is only preparation and stuff, but this is our actual implementation, which resulted in the app I've shown you before. So simple as that, we have just a regular implementation using the async pipe and iterating over our movies via ng4. That's it for now, and we want to add now our context information with native implementation Angular gives us. So I've prepared the next step, and I will just show you how the easy refactoring, so the start refactoring, would look like in the template. So what we needed to do now is we need to move the binding from our state one level higher. So if you compare it to this implementation, here we use the async pipe just to show our movies, but we actually want to have the non-existence of the value. And Angular gives us a little hack, and this is the async as hack. So in this case we say as long as state, So the value that comes out of it is nothing, then in else case show us the loader template. And this is our loader template here. So with this setup in place, we already can start and try to display our loader as long as we have no data. So I need to change this one again as well, because here we have only state, it's actually movies. I could call it movies, that's maybe better. And if I refresh now and quickly check if everything is alright, looks good. So reset the application, and there we go. We have our first loading spinner implementation, just with native Angular async pipe and ng effect. So that was very unexciting, but still looks clean. That was not much of an effort. Let's move one step further. So now we want to have our error context in the template as well. What we're doing now is we add another ng-if condition inside of our template and say, okay, we now need an error property which indicates us that there is any error in the template which we can display, we can use to display another template. So in this case, if error would be true, we want to show the error template. For this to work, we need to refactor the component a little bit and adjust our code which fetches the data. So we go here, and we had before just a call to our data service providing us a list of movies, and we need to actually change this behavior to something that looks more like this. So we fetch our data at this point, then we need to map it. I mean, we don't need to do it here, but for simplicity reasons, we are turning our array of movies into an object with a movie property and an object with the error property. So we use the catch error pipe from rxJS here to catch any error that passes our stream and return instead just error true. And with this setup in place, we can now call this back against state, and we have an error property, and here we can use our movies property, refresh the page, and look what's happening here. Very good. So hitting reset shows us the loading spinner, hitting error shows us also the loading spinner, but then results in our error template. So this would be the first step we can do just with Angular native coding style. And actually, if I go into the code and look at it, I don't really feel uncomfortable at this point in time. And the question is, can we improve that? And can we make it simpler without more work? And now I need to introduce you the let directive. So the let directive gives us the opportunity to get completely rid of the ng-if hack at all, because this is a structural directive called rxLet, which just takes whatever we give to it as observable and derives whatever is needed to switch between templates internally. So it will take off the work you needed to do in the component, and now I can go back to the component and just revert all the refactoring I did before. So I will just remove this one here, where we mapped everything around and caught the error ourselves, and just provide the let directive with our stream as it was before. So this should work right out of the box. What you can see here, in case you wondered, is we bind here our value. This is our state, so our observable of movies. And this is its implicit context. So we just read it from there and define it as let movies, and that's it. I could call it state if I want, but since we are only getting movies here, I'll call it movies. Then you see the two input properties here. We have rxSuspense and rxError. This is a proof of concept. Naming is not set in stones, but we use it to set here our templates. It should switch to whenever it is in suspense state or it is in error state. So whatever we had done in the component before, we just give it for the state. Okay, in suspense state, show me this template. In error state, show me that template. And now I go back to our template, to our application, reset it. We see the loading spinner appear, we see the list appear again, and in case we want to produce an error, there we go, there's our error template. And what we actually did here now is turning, I mean, it's not a monster, but you had to do several manual ngIf conditions right here in the template, and in the component you needed to refactor the stream in order to do all the work on your own. And the rxLet directive does that for you. So that would be the first part of the demonstration. And I would go back to the slides again. Let's do a quick...
I have a question.
Yes, please.
Back to the code, please. So this rxLet is a custom structure directive that you have created which takes an observable and then manages the state within, right?
Exactly. So whenever the observable hits one of the context states, which we defined as I introduced before, then you can give it potentially, if you don't define any template, there are other possibilities, and we will come to that later. But you can define for each state, so there will be a complete state as well, like rxComplete, and you could define a complete state here as well. So that's the intention of this specific feature set, that you can map state to template, and you don't have to manage it on your own.
And when the observable is resolved, it automatically fires the rxComplete and calls the complete template automatically, right?
Exactly.
Okay.
That's the idea behind it.
I have one question too. Do you have access, in the error template, do you have access to the error message? Like, there will be some...
Yes and no. Like for in the future, definitely. That's the plan. I don't think it's implemented in this proof of concept.
Local variables.
Yes, there are other ways to keep the latest state and still show error messages, but not with a specific error template outside of the list. But we will come to that.
I have one more question. So these are the template variables, right? Here, loader and error. Is it also possible to pass the component there?
A component?
Yeah, directly, just throw out the component.
I will just note it down here because that's a great idea. No, it's not possible.
But with a component outlet, you could do it in another one-liner.
Yes.
The component outlet on top of it, like where we have the binding, and then it works. You can just throw components in that directives too.
Okay. I mean, you could define your component inside here, inside the template.
Even the component reference could work, no?
Yeah, component ref should work, yes.
But I mean, resolving the component is also something asynchronous.
Shouldn't it even work just with component type in the
There is a
creative?
workaround.
Okay. So then let's do a quick recap of what we have seen right now. So what we've done here was using the lifecycle of the observable to determine the the template we want to show, and the value was non-existent. We showed a loading spinner. We had a value. We showed a list, and in case of an error, we showed an optional error template, either this or that. So that leads us to the next thing, and now it's time for context variables, to context variables, because what we have done now so far was switching a whole template. We switched to a completely new template, we erased the complete list, we had no data left, but for the sake of the first example, it was nice and okay. But what if we want to keep our list while still be able to show a loading spinner, or still be able to show an error message as a pop-up, or whatever notification bar? And this is where context variables come into play. So what we used before were context templates. We mapped context to template, but it's also possible to use context variables. And this leads us to the next demo on the roadmap, implementing a stream of data. Because here we don't want to switch to the complete template after everything is completed and erase the list, but we want to have some kind of notification for the user displayed next to the list. And that's the point where we go back into the code. So No, we start with the application as always. So we hit the next route, which is called multi-shot, and there you already see it. This is a stream of data which ends, I think, after 4 movies. So if I reset, you can watch it again. Like a feed, our data appears like and is at some point in time complete. We have again our control buttons, and now what we want to achieve is to have a notification for the user that when everything is fetched, it should be visible. So using the complete context. And of course we need to keep our list, because otherwise it would be senseless to, hey, list is complete but gone. Okay, so let's go to the code again and introduce the next set of demo components. So switch to demo 2, yes. And we again start with the TypeScript code. So the setup is the very same. We just have a state creation method, and we did what we have done before. We create for our async pipe implementation a state object which we can use in order to control our properties to switch in the template. So this looks actually like the last final implementation for the async pipe. And in the template, it's the very same. So we have our ngIf async pipe hack, else we display the loading state, and internally we use the error property when an error occurs. But we want to add the complete state as well. And now let's try it this way, just with the async pipe. So we want to introduce a new property called complete, and we can use the rxJS operator function end with, which will wait for the stream to end, so the complete event to fire, and we switch to a new value called complete true. So let's refresh this and take a look in the browser. Exactly. List finished, switch to the complete template. But list gone. What we want to have is, we want to display this notification here and keep the list. Thing is, doing this with the async pipe would now cause a bunch load of code, because we need to introduce some caching mechanism. Whenever the data pass by, we need to remember them, and I would need to implement, I think, at least 2 different side effects, which should just be a stream of data. So let's directly switch to rxLet and see what context variables can provide us here. So I can actually just erase everything here, and yet again for rxLet use just the stream of movies, which will give us our values, and let rxLet just do the work for us. So get rid of this one here. And say hello to rxLet again. So same setup as before. Is it large enough? Yes. We bind our observable value here. We let rxLet give us its implicit context list of movies. We define our suspense template and error template, and that's what's new here right now is we want to be able to read the complete state. And what we are doing here is we define another variable just for the template to have it sitting next to the values we displayed before. And complete, like $complete is the current name. We should think of a new name probably, but we define C here as a Boolean, which indicates whenever our rxLet receives the complete event. We can now use our Boolean value, let's see, in order to use a switch here in our template. So whenever C is true, then show me the complete state. Looks very similar to the async pipe implementation, but let's take a look at what's the difference. Was there a question? Okay. Okay. So we have kept the values, plus we notified our user, our stream ended, and without any implementation inside of our component code, it was possible to derive everything just from this directive. That was. Thank you for your drinking pauses.
I'm too excited.
Yeah, it's very good. Me too, by the way. Okay, said 2 minutes before, where I talked about we need to do some caching mechanism. So I need to introduce some kind of movie cache which stores our last list of movies in order to keep them displayed while still switch to our loading state. So what we are doing here is kind of the same as we did before. Like on search term switch, we go to our service call again and use our term we typed into our input box, call the search movies API, and whenever we receive a value, so we are here receiving the latest result, we want to cache it and return it again as a state with movies properties. What's important here is to in order to show our loading state, we make use of the start with. Before we used end with, but now it's start with. So whatever you do, but this is your first emission, and first emission is cached movies plus loading true. And this should do the trick for us in order to maintain a loading state in our template with async pipe. So let's check. I think we don't need to touch, yes, we need to touch the template as well. So yes, exactly, because with this in place, we wouldn't be able to show the loading template next to our list because it would ngif out this complete div. So what we need to do here is kind of like this. We get rid of our then condition here, so we don't use the suspense state, but we use our loading state, loading property, which is now in our state, and then show our loading template. So if I refresh this now and go to our template, let's start fresh with reset. Very nice. And now I can search for Batman as well. So that actually did what I wanted. Display the latest list of movies while still be able to show some kind of information for the user while the search is in progress. And now, yet again, we want to switch to the let directive to do everything just magically for us without having to struggle with all the complexities in our component. So we go back to our template and get rid of everything what's written here and introduce yet again our let directive. And now we already have a bunch of input properties. We again use our state, bind it, read it as our implicit state, that's why we don't have to put equals here. And what we then need to do is showing our suspense template as we did before with the complete next to our latest value while switching back to suspense. And what's new here is all of this. So basically, them are the trigger inputs, and the trigger inputs receive yet another layer. So that are the template triggers I've explained before, which is which the rxLet directive can also derive its contextual state. So whenever our next trigger or complete trigger emits a signal for the let directive to switch the template, it can switch the template or add the context variable even without the original bound source, so state, emitted it in the first place. And that's what makes it possible to switch between templates. And yeah, let's check it out how it looks in our example. It's complaining because I need to refactor the component back because, as always, we don't need to touch our stream, we just need the stream. So going back to our initial state in our component, just the need of the stream and triggers in place. Maybe interesting for the triggers so that you don't wonder what's happening here. We have our search bar, and when our search bar receives an input event, we go to our search method, and this is actually what I've told you before. Like we kick off a new async operation, and right before we just trigger suspense. And this is the sign for rxLet to switch its template. So check it out. In the component itself, initial load looks good. Trying this one looks good as well. And if that wouldn't be all, now we have those funny buttons here, and this is the most amazing part, I think, because these will trigger those template triggers, and we now can just iterate over any template we want. If I hit suspense, we will see the suspense state. I can go back to next, just the list. I can show a complete template into an error, into the latest next value, and so forth, and so on and so forth. It's never ending. And that should be it for our last demo so far. And before we have, I answer questions to this one, because I have not much left to say at all. Let me go back to the slides. And thanks for listening. If you have any further questions, please ping me. Even wait a second. Even now or later via email. And one last thing. Sorry. Start us on GitHub.
There's one too. Perfect. Every question will receive a number, and every question can take place on our raffle after the second talk, so feel free to ask a lot of questions. You are in best case raise your hand, and then I will do the first one.
You're doing this stuff. That's good.
You don't need a mic? Okay. Can you give me a number?
Need a second mic?
My question is, how is it actually fixing the cache problem that you mentioned with normal Angular operators in rxContext?
Thanks.
Oh, this man is a 41?
Maybe the 41?
I thought we didn't have 41 anymore. Sorry. I
Okay.
think we don't have one. So
No problem, I will just speak as loud as I can. Okay, how does it fix it? Because when we go to the code back, this is what we had to do for our async pipe implementation. So we had to manually take care of our caching implementation here. So in order to display like the loading state plus the latest movies we wanted to, or latest data we wanted to implement, every time we received we received a value here, we needed to make sure to save them in a cache, and so that we can reuse it when we kick off our next search command. So this is the place where we kick in when we enter any character in the search box, and whenever we receive a value, so search result came in, we need to cache the latest result in order to kick off any search with the latest result we received, because otherwise the template would be gone. And I can maybe, if I just turn off the cache here, then wait a second. So if I just turn off the cache here and make it just a regular array and don't emit anything, or just not emit it here, that's the easier part, I think. Go here, go to the demo again, and don't use rxLet, but use async pipe again. So here we are, that should be our final implementation, yes. Go back to the application, and if I now hit the search, the list will disappear because I have no cache value anymore. Because our state gets updated in our template with loading true, but movies is empty. So whenever we kick off the next search, we want to have the latest state of our movies as well, otherwise they disappear because the array is empty.
And how do you maintain it in rxLet, for instance, if I may ask?
The implementation looks like similar to something like this. We also have to do some internal caching mechanism, but the thing is, the library is not only about performance but also developer experience. So you don't have to do this one here.
And I guess you would already, if you are using ngrx or something, you would already write that boilerplate. Oh, sorry, it is not a question, but if you would do this with ngrx and create all of these variables or states in your boilerplate, then you would just repeat it, and you are basically writing the same code with error, with loading. With
Exactly.
The suspense is new.
The suspense is the new one, exactly. But this was about how we can derive it directly from our data source. If you fetch it from state, you won't ever have a complete or something. But for scenarios where you search or something, that's really good and really handy like tool. Yes, please. Or are you happy with my answer, Puerto?
Okay.
So speaking of performance, do you make use of on-push strategy, or does it support on-push strategy with all of its benefits?
It even does support zoneless implementation with all of its benefits.
Okay, and the other question, when I would use the debounce time, I could maybe get rid of all this suspended function and suspended trigger, right? It would be nice to just say rxLet, I have a debounce time of 200 milliseconds, and I would not need to implement a suspended trigger and suspended function and just work with the observable or behavior subject directly. You know what I mean?
Yes, I think so. So if you would do just use the stream, but what should be the trigger then?
It should just, I mean, RxJS will, I guess, internally understand this, that the debounce timer has been started, right?
But what visual feedback will give?
I think that's the problem we have, because we need some kind of trigger in order to inform our directive that this is the point in time where we want to switch our template.
The feedback is the suspense. You already have the $suspense variable. So the same thing, like I just want the variable to be filled automatically without the suspense trigger.
I guess that's the case too. Yeah, the question is if you can get rid of the trigger, explicit trigger, just by using.
Yes, exactly.
Yeah, but not for switching. Like if you want to switch, so whenever the trigger is only here for exactly this one here. So whenever we hit search, so we type, then the trigger kicks in. But the initial suspense still stays, gets read from the context.
You don't need the trigger at all.
Okay.
Just if you explicitly need it, you can use it.
Okay, so this is just a use case that is not making sense in this case because I can just use it. Okay.
Yeah, if you look at this slide here, so this is actually what we did with the search. So we used initial loading spinner from initial suspense without the trigger being involved. And we showed a list. Then we hit the search, so entered any character in the input field. And then we hit the trigger to just switch until the next value kicks in.
But if I use the debounce time operator, will this one trigger immediately or after the debouncing?
That depends on the implementation, I guess. I mean, for what do you want to debounce the stream of data?
That's the input. The user types, and I don't want to
search
immediately.
Sure, it would work. Yeah, sure, it would work.
Okay,
exactly
cool.
like that. Mm-hmm.
Okay, great.
I have to need to inject or import something to trigger the events, like the trigger suspense. You have a method for trigger suspense. What are you doing in this method?
Okay, yeah, I didn't show off that one. Nothing too fancy, just next thing, avoid subject.
Okay, you have to bind
all the triggers, like the trigger inputs are observables as well.
Okay.
Mm-hmm.
One question to you. So isn't this a lot of way? Doesn't this actually include a lot of subjects, for instance? So you have complete trigger, suspense trigger. So it now depends on if you further go on implementing more such triggers in your rxLet structure directive, it would mean that you would end up, like we would rather end up in adding more subjects, and then you would have to use that in your code, right?
Yeah, right. I mean, right now this isn't released yet. It's still a proof of concept, and this was the implementation just for the talk to demonstrate all the feature sets. But I could imagine actually use something like enum or something, where you just need one trigger subject which emits a type of event you want to emit. That would be possible as well. For now it's like 4 different inputs, which everything is depending on a void input. Yeah.
And maybe
Or signals.
Or signals, yes.
maybe instead of subject, rather than a subject or behavior subject with an initial value. Oh, yeah, that's an idea.
Maybe jump, I guess.
Yeah,
initial
open an issue and then raise a PR.
Initial values would not make sense because it is a button click. How can a button click have an initial value? You have to think about signals that like signal a change in.
What I meant was kind of the initial loading state. If you have to show, for instance, the movies that are showing up on the initial render, so that is also a state.
I'm not getting it. But you can open an issue at the.
I guess this already exists.
Dummy data. Ah, yeah. Yeah, so you have templates, you can put any dummy data there you want already. And dummy data are not really right, they are static, whatever dummy, so it's not a really fetch.
Okay, perfect. I think my question already cleared up, but just to make sure, the suspense trigger in your example is just needed to signal the new input data changed in the search bar. So the background loading takes some time, but it already triggers the loading state when you change the, because it feels a bit like you're doing the same thing twice with the triggers, or suspense trigger. Not here, but where you call it. But yeah, and I think is this in reset, or where you call this trigger suspense function?
Trigger suspense happens on every search.
Exactly, and okay, so this just signals that the loading has started.
Yes.
And search them. Okay.
Exactly. This triggers that the loading has started, and
Yeah.
whenever our stream of data, like where is it? This one here, emits a new value,
Yeah.
then it will switch automatically back to the source's emission of next.
Okay.
So the trigger is valid until the source emits the next state.
Perfect. Thanks. That clears it up.
Rather stupid question. Is it intentional that you choose suspense as a name for this trigger?
I think so. We're using it a bit to write on the suspense and what is it called? React concurrent mode. We try to compete with it and make it better.
Good job.
Maybe it was discussed before, but I did not fully get it. If I'm using ngrx store already, does it make sense to use this, or would you rather not use it?
Sorry, I didn't get the name of the...
ngrx store.
Ah, yes. I mean, this very example was heavily depending on that you just fetch data and display whatever state comes out of it. But I mean, for a search implementation, it is also cool to have like something where you can on a trigger switch templates until the next value comes in. I could see this coming in handy even with ngrx in place. Other than that, I think every feature is. There are other features which we didn't talk about. This was only about the context we can derive from observables, but you will still love using it because it's just faster than the native implementation. But that would be a topic for a different talk now.
You have ngrx already, I guess you would duplicate state. Because you would have it already in state and then in RxS.
Marek.
Oh,
sorry.
Okay.
Sorry. Didn't say.
So we defined in the rxLet we defined the movies,
And my question is, are these then checked by the compiler that it's the right type when I use the movies and all the other things I define in the rxLet?
Yes, it would. It derives the correct type in the template. So if I check it here, like just hovering over, is it possible to see it? State movie, very small, but yeah, you can see it. My IDE auto-completes the state for me. And if I would turn on strict mode in this demo, then everything would break, but yeah.
I know it is probably a topic for different talk, but why is it faster than native implementation?
Okay, good one, thanks. Yeah, well, it's faster because rxLet will actually, like in comparison to the async pipe, not run the whole change detection cycle, but apply every change that's passing this observable to only, can I somehow close it? No. To only this part of our template. So only this, like it's called embedded view. rxLet spawns an embedded view from us and for us. And whenever we have a new value or we need to switch the template, only this part of the template in the component will be re-evaluated, and we are not in the need of calling mark4check, marking every component in the tree up as dirty, and then wait for zone to kick in to re-render like everything you have passed on your way, but just this template.
Sounds good.
Any more questions? Yep. But this is on push change detection. This would make no difference, right? Because it would also not trigger up the tree.
I guess this is what most of the people don't get.
Yeah, that's
The async tab renders always everything on the path to the top, like we're top down. Sorry.
So in order to render this change with this implementation here, so two things happen here. State emits a new value. What does async pipe? Nothing special, it will just call mark4check. What does mark4check do? It goes up the tree of components to the very top, to AppRoot, and marks everything it passes this pathway. So if you have a button, like think of a leaf component, button with loading state. If you have async pipe in it, then you have in your most leaf, you just want to switch one template to loading spinner. You don't need to inform every component up the tree. And then nothing happens until ngZone kicks in and checks each and every template which you passed and marked as dirty to re-render it. And rxLet just doesn't do anything but updates the template.
I will check this.
There was actually a video also of explaining this change detection.
Michael did a great talk about it, I think.
Yeah, maybe we do it physically again in some months.
Good idea.
Why not? A lot of questions. I guess you need a break. And
awesome.
Maybe one final applause.
So